Hello dear students.
थोड़ा जोरा
Hello dear students. So we come to part 5, lecture 5. That is of the topic halogen derivatives, and today we are going to see what we mean by optical activity. The last time we have seen what is meant by optical isomerism, what are the terms that are very useful or very important to learn or to understand optical isomerism. Like we saw chiral carbon atom, we saw non-superimposable mirror images of each other. Okay, so all this are very important to study the next important point, that is optical activity. So this optical activity is to do with optical isomerism. So we have just seen that isomers are two or more molecules having same molecular formula, same structure, same molecular or chemical formula. Bond connectivities are same, but they differ in their optical activity. That is, they differ in the arrangement of the atoms or groups of atoms in space, spatial arrangement. And so this is also a type of stereoisomerism. Alright. Now when we have to study optical activity, optical isomerism giving rise to an activity which is called as optical activity. And when we study optical activity, we must again study the terms that are important for understanding this activity. Okay. Now the very first term that we have to study is plane polarized light. We can also write it as PPL, plane polarized light. Now in order to understand plane polarized light, I have just drawn a rough figure, you can say, on one side of the board. Okay, so you are quite aware that an ordinary light, see, this is an ordinary light, or you can say this is a cross section of an ordinary light. Now this ordinary light has oscillations of electric as well as magnetic field in all possible directions. So see, they are shown, these oscillations in all possible directions. Okay, right. So this is an ordinary ray of light is made up of, you can say, light having oscillations of magnetic as well as electric field in all possible directions. When such a light, ordinary light, is passed through Nichols prism. Now Nichols prism is a special type of prism. Okay, it is very useful to learn optical activity. When this type, ordinary light, this is the cross section, remember, is passed through Nichols prism, the light that emerges out will contain the oscillations only in one plane, only in one direction, perpendicular to the plane of, or perpendicular to the direction of light. And such a light, ray of light, which has such a ray of light which has its light emerging only in one plane, that is called as plane polarized light. Okay, so plane polarized light is a light, ray of light, or having oscillations in a single plane perpendicular to the direction of propagation. So very important, plane polarized light. And it is this plane polarized light that has to be used for studying the optical activity. Okay, so again I repeat, the light having oscillations in a single plane when an ordinary light is passed through Nichols prism, that light that emerges out is called as a plane polarized light. Alright, so once we know what plane polarized light is, we go to the next term or the next, you can say, definition. This definition will help us to learn the definition of optical activity. Alright, so we go further. Did you understand? Okay, I'll just rub out this. Now we saw how plane polarized light is emitted. Alright, now this plane polarized light is very useful for studying optical activity. So when an aqueous solution of certain organic, now what are we going to? We are going to the next point that is very important, and that is optical activity. Okay, so when an aqueous solution of certain organic liquids like lactic acid, 2-chlorobutane, is placed in the path of the plane polarized light, then the transmitted light that will have oscillations in different plane than the original. So see, now the arrangement is going to change. There is going to be an optical rotation, and this activity is optical activity. So now when we pass this, we take plane polarized light. Okay, I have already given you, we'll just, and when you take a certain organic liquid, okay, aqueous solution, you take an aqueous solution of certain organic compound. Now which organic compounds? Those which contain at least one chiral carbon atom, like 2-chlorobutane we have seen earlier. Okay, or you take lactic acid, and there are so many more where one carbon atom is attached to 4 different atoms or group of atoms. So that is containing one chiral carbon atom. Okay, you understand? Plane polarized light, aqueous solution. When this aqueous solution of such a liquid organic compound, such a aqueous solution of such an organic compound is placed in the path of the plane polarized light, then the light that emerges out, okay, then the light that emerges out will have oscillations in a different plane than the original. Okay, and accordingly, this property of a substance by which the plane of plane polarized light is rotated either to the left, that is the clockwise direction, or either to the right, left, that is the anti-clockwise direction. This phenomena of rotating the plane of plane polarized light is called as optical activity. The phenomena, the whole phenomena. First we saw what is plane polarized light. When an aqueous solution of certain organic compounds like 2-chlorobutane or lactic acid are placed in the path of the plane polarized light, the light that emerges out will have transmissions or will have oscillations in a different plane. Okay, and likewise that will be rotated either to the right or it will be rotated to the left. They will have oscillations rotating in the right direction, or that light will have oscillations rotating in the left direction. So if it is rotating in this right direction, this is called as dextrorotation. Correct? Or you can also call it as clockwise rotation. If it is in the left direction, correct, it is called as levorotation, or it is anti-clockwise rotation. Did you follow it? So this phenomena of rotating the plane of plane polarized light, when certain aqueous solution of certain organic compounds are placed in the path of the plane polarized light, contain the light that emerges out has oscillations in a different plane from the original one. The whole phenomena is called as optical activity. So there is a change in optical rotation. Either it is rotated to the right or it is rotated to the left, and that through how many degrees it is rotated, that is called as angle of rotation. Did you get this? Angle of rotation. So how many terms have we seen just now? Plane polarized light. Then we have seen what we obtain when this plane polarized light is subjected to this activity. Okay, and the whole phenomena is called as optical activity. Okay, optical activity. Optical activity. Now, how will you define optical activity? So, see here, the property of a substance by which it rotates the plane of plane polarized light either to the right, that is the clockwise direction, or to the left, that is the anti-clockwise direction, is known as optical activity. Okay, so see that you write down the definition of optical activity. Property of a substance. Optical isomers are also called as enantiomers, or they are also called as enantiomorphs. Enantiomorphs. Okay? Okay? So, optical isomers. So, likewise, the one which is rotating the plane of plane polarized light to the right is called as dextrorotatory enantiomer, and the one which is rotating it in the left direction in the anti-clockwise, it is called as levorotatory optical isomer or enantiomer. Alright. Now, what are enantiomers now? They are optical isomers. Molecular formula is same. Structural formula is same. Only they are differing in their optical activity. Right? Optical activity. That is, one is rotating to the right, the other one rotates to rotating the plane of plane polarized light to the left direction. Okay? And so these enantiomers are denoted, if it is in the clockwise, it is dextrorotatory, you denote it by plus, correct? And if it is in the left direction, you call it as levorotatory and you denote it as negative, correct? So see, so important. So enantiomers are optical isomers, and the whole phenomena are exhibited by these optical isomers is called as optical activity. Correct? Alright. Now one more important point that we have to see. One more point that we have to see about enantiomers. Now I will define enantiomers once again. You followed this? Okay. How will you write down the enantiomers? What are enantiomers? How will you write down the definition? Enantiomers are the optical isomers. Which are what? Non-superimposable mirror images of each other. Correct? Of each other. In which one of the enantiomer, if it is rotating the plane of plane polarized light in the clockwise direction, the other will rotate the same in the anti-clockwise direction. Did you follow this? So clockwise and anti-clockwise, and so they are shown as dextrorotatory, levorotatory, shown by plus, shown by minus. Remember this point, non-superimposable mirror images of each other. Alright. Now this enantiomers, if you take 50% or of each isomer, of each enantiomer. So if you take 50% of dextrorotatory enantiomer and you take another 50% of levorotatory enantiomer, what will be the resultant? A mixture will be formed. Okay? And that mixture is called as a racemic. R-A-C-E-I-M-I-C. Racemic mixture. Okay, so another term now. Racemic mixture, or you also call it as racemic modification. Okay. Now how will you define racemic mixture? An equimolar, okay, mixture, an equimolar mixture of enantiomers. You can say enantiomers you can say optical isomers, right? Or you can say dextrorotatory, levorotatory forms, correct? Modifications, which is optically inactive. Okay, this is called as a racemic mixture. So racemic mixture is an equimolar mixture of enantiomers. Which enantiomers? The optical isomers, that is dextrorotatory and levorotatory, which is itself optically inactive, because if one of the enantiomer is rotating the plane of plane polarized light to the right, the other rotates at the same time the plane of plane polarized light to the left, and so the net resultant is 0. So we can say that a racemic mixture is optically inactive. Okay, and that is due to external compensation. Optically inactive due to external compensation. One is rotating to the right, at the same time the other one is rotating the plane of plane polarized light towards the left, and the net resultant is 0. So it is optically inactive, and that is called as or it may be due to external compensation. Okay, it's not mentioned in the textbooks now, but this is for your extra information. Alright, so here we have seen this phenomena of optical activity. So when we learn